Greetings, ladies and gentlemen. My name is Giedrius Kaveckis. I'm the master student from Carinthia University of Applied Science in Austria. Now I'm writing my master thesis in Policy Center in Indianapolis, United States. My personal interests are emergency response, flood risk, and flood hazards. The main reason why I'm visiting Policy Center is the creation of the semi-automatic data conversion scheme, which would allow us to integrate non-U.S. datasets into Hazus-MH. The existing problem of the Hazus-MH is that the software is capable to work only with U.S. datasets. This presentation will show you the implementation and the framework of non-U.S. data integration and what free available data is possible to use in Hazus-MH flood model. This implementation works with older and new Hazus 2.0 version. So far it is capable to integrate site-specific facilities like hospitals, police stations, schools, oil refineries, bridges, and other buildings. It is still not available to use aggregated data, but this could be solved in the future. Because of the limitations of the common aggregated data in Europe, it was decided to use European administrative units. Instead of county, tract, and block, 3 NUTS levels were chosen. Part 1. The creation of the study region in Europe. From now on, I can slow down and will introduce you the Hazus-MH software. Hazus-MH is an abbreviation of Hazards US Multi-Hazard. This tool is a powerful risk assessment software program for analyzing potential losses from floods, hurricane winds, and earthquakes. As you probably understood, in this presentation I will focus mainly on the floods. Hazus-MH was developed by FEMA, Federal Emergency Management Agency. This free tool works as ArcGIS extension. Over there you can see the new possibility. Instead of US states, you can choose European countries, if more precise, sometimes even the regions of the countries. Practically, there is no geographical limitations. South America and other continents can be also very easily integrated. Also, there is the possibility to use the map by choosing the region. You can navigate and choose wherever you want, even the multiple regions. Right now, when the level 1 NUTS region was selected, depending on the decision made before, we can choose the second NUTS level region, which is named in Hazus-MH as a census tract. Then we just create the region and wait until the tool will generate it. When the region is created, we need to open the region. First, what I will show to you that by default there is no data in the region, the data inventory is empty. The Hazus-MH users in the United States had the possibility to use the default inventory data, but in this case no. Default inventory is not available for Europe. So far. In the future, who knows? Everything is possible. In the second part, I will show you how to integrate already prepared data. I will use the tool which is delivered together with Hazus-MH. It is CDMS. What I will do first, I will open the CDMS software, but before the integration process, I would like to show you the input data, the fire stations located in the Excel sheet. All the data must have strict defined structure and attribute information. Some of the attribute data is not used in the analysis, so it is not compulsory. Now we got back to the CDMS screen. CDMS is the quite useful tool which simplifies the data integration, originally for the US datasets, but I'm using it for my own needs. First, what I need is to choose that I'm interested only in the floods, then search for that Excel file where the fire stations are listed, and then select that it is essential facility, and if be more precise, the fire stations. By the way, do not pay attention to the left bottom screen. The current state California. If it will help you, you can think that at this time when I was creating this presentation I was in California. Anyway, I'm still in Indiana and I don't think that it is so bad. The next task is field matching. It means that we have to identify the existing fields in our dataset with the fields which are needed to perform the analysis. The model must have the links where from it should take the information. After the field matching, we can see the value matching. Hazus-MH have the specified values for each model, like they should be specified foundation or occupancy type. If the names in the input data are not correct, we have to match them with the Hazus-MH value. And we are almost at the finish. We just choose the type of transferring the data to our default inventory, then just transfer it and wait for the confirmation. So when we integrate the data via CDMS, it will stay every time when we will create the new region. That is why we need to recreate the region. I will not show that again because you already know how to do that. I'm going straight to the inventory of recreated region and choose the fire stations. Here it is, and I can visualize them on the map to get the better view. The next task is to prepare the flood hazard data. We must use the user-defined flood depth grid, so we choose the flood hazard type and in the user data browse for the user-defined flood depth grid. For sure, the depth grid must be in the raster format and like all other input data in NAD83 projection. The parameters are like units and return period. I think with the return period everything is clear. With the units, if you choose the meters, model will convert it automatically to feet because model is from the US and he doesn't know meters. When a depth grid is imported, it is the time to create the scenario. Scenarios are needed to choose the inundated areas and choose the different properties. It can happen that the flood depth grid consists from few segments. Each scenario has its own properties but the same inventory data. Because it is the user-defined depth grid, there is no need to perform hydrological or hydraulical analysis. The model only defines the inundated area according to the important depth grid. Looks like the flood hazard and inventory data is prepared. Then we can run the analysis. For the point data, the analysis is quite fast. The model checks every point. If there are thousands of points, it can take some time. The analysis is finished and we can check the results. And as you will see, there are no results for the fire stations. And also you will see why that happened. That happened because there were no fire stations in the inundated area. It is good in the reality, but for this presentation, no. And now I'm showing how we can check that there were no fire stations in the inundated area. Unlucky presentation. I will try to recover that. Now we will import the user-defined facilities. I got some of them from the OpenStreetMap, processed them and saved to the geodatabase. Here you can see some attribute data. Later I will explore the framework more in details. Now we just open the user-defined facilities and choose to import them. Choose the file, choose the table and match the fields. It's quite similar as CDMS. It's said, but there is no value matching in this case. Here we go, we have a list of user-defined facilities. We can map them and we will see that all of them are in the inundated area. Lucky me, maybe this presentation will go better than the last one. So we just run the analysis again and wait until the confirmation window will show up. Now we should get some results. What you can get from user-defined facilities are the building damages in percentage or in monitor value. The same with the contents. The damages are assessed according to damage functions, which are defined by occupancy class and the foundation type, as example basement. There are many parameters which should be considered and they will be. Also you can see the possibility to map the results easily, the standard ArcGIS procedure. The same as to find out the total damages. Quite useful.
And for the conclusions, what I did over here, I imported the site-specific data and user-defined facilities as the Hazus users do in the US. Nothing special. So what you would need only the good and well-prepared data. In my thesis, I will publish the requirements which should be followed to get the data into Hazus-MH. So far, there is no possibility to use the aggregated data efficiently, but I'm working on that.
Now I think it is more interesting part for this who does not have the data at all. As you remember, for flood damage estimation the two main inputs are needed. It's flood depth grid and inventory data. In this part I will show you how simple it is to get this data for almost any country in the world. But not be very happy, I'm not sure about the quality of these inputs. It is still needed to do some more analysis. But it is better than nothing. Also, sometimes we should think that the bad decisions by using wrong data can damage more than no decisions. I would not recommend to use this methodology for significant studies so far. And now I will create the study region again. But this time I will create the study region in my home country, Lithuania, by choosing the census block, the smallest unit, which would be NUTS 3 region for Europe. And I will choose the Vilnius region. And proceed further and wait until the region will be created. The same procedure. Open the region. You will notice again that there is no inventory data, no user-defined facilities, nothing, even we don't have the flood depth grid. I would like to start with that issue now. As you probably know, to get the flood depth grid, the digital elevation model is needed. There are existing few solutions like SRTM, shuttle radar topography mission with 90-meter resolution, DM or ASTER, advanced spaceboard thermal emission and reflection with 30-meter resolution. I decided to choose the ASTER for the high resolution. So you go to the website, register over there for free and go to the search window. Over there you will have many possibilities how to select and download the tiles which you will need for the flood depth grid. You can select them by mouse, by polygon, select by coordinates, or even you have the possibility to select them by shapefiles. When you are sure which tiles you will need, just square them and download. Also, small advice, Hazus needs these tiles to be in the grid format, not TIFF, so you would need to convert them. Easily that can be done with ArcGIS. Maybe in the future also I will implement this as a tool. We have a DAM. Right now I will not show you how to process it and to get the correct DAM. We will leave it because first what we want is to get all needed raw data. So we will proceed further with the building data as user-defined facilities. This solution I found few days ago. Maybe some of you already know the OpenStreetMap, where users can easily upload, download and browse the data. This project also was used in the Haiti earthquake in 2010 to map the damages and for other purposes. Now I will use it to get the user-defined facilities in Hazus-MH. The problem is that the quality of the data is unknown. We can't be sure that the map buildings are really where they are in the OpenStreetMap. We cannot be sure that the occupancy is correct and so on. But as I mentioned, it is better than nothing. So let's take a shot. I downloaded the OpenStreetMap as a OSM file and used quite good free JS software, QuantumJS. In 1.6 version I found a plugin which is capable to convert OSM files to the shapefiles.
There are some more solutions also available, but I will not describe them over here. So first, open the software and enable the plugin. Then browse for the files. We have the line, polygon and point layer. I will show you also the attributes of both of these layers. The amenity column looks like what we need. We could use it as an occupancy class in the Hazus-MH. Let's save both of these layers as shape files. We have the raw data, so just go straight to the point. I use very simple methodology which should be applied only for the small interest areas. Just subtract flood water elevation from the DEM and you will get the flood depth grid. No hydrological or hydraulical analysis. I have created also some tools to proceed easier using that methodology. Let's select to add the interest area. It's a polygon which will delineate the boundaries for flood depth grid. Run the tool, which will create the polygon layer. Add the data and edit the layer by creating the new feature, your interest area. Do not forget to save the data when you will be finished. Next, we will run the tool to create the flood depth grid. We have the interest area, we have a DEM, and we need the flood water elevation. I want to ensure you that it is not the return period. It is simple flood water elevation. It can be historical, marked on the walls by years or similar. In the model, choose the needed layers and input flood elevation. Run the tool. To be sure, add the data and you will see the flood depth grid. I want to repeat that the quality of this methodology is still not clear. U.S. Army Corps of Engineers approves it for the feasibility study, but leave this question for the future. Let's process the building data, which we got from the OpenStreetMap. I have two layers of buildings, point and polygon data. Polygon data are the blueprints of the buildings. It is clear with the points, quite easy, but more challenging with the polygons. I will show you how to process them. First, get rid of irrelevant data. Just sort the buildings by occupancy and delete all the records with no values. Simple operation. Let's assume that the buildings would be in the middle of the polygons, so run the specify tool, which is the same as the conversion of the feature to the polygon in ArcGIS. For Hazus-MH, the additional two columns are needed, x and y coordinate of the point. Before running the tool, do not forget to reproject your point data to NAT83 projection. When the layer has these two columns, use the tool to export it to the geodatabase. Specify template. Template can be opened by Microsoft Access. Further actions will be done with that software. Hazus-MH has its own occupancy classes and can't be understood by OpenStreetMap classes. That is why the relation table is needed. I created one for this case. Maybe you remember that in user-defined facilities we do not have the possibility to match the fields. That is what I did with the table. I defined the OpenStreetMap occupancy values to Hazus-MH values. Everything what we need to do, run the queries. Few mouse clicks, and your occupancy column is updated. But still, this data structure is not familiar with the Hazus-MH data. That is why we need to run another query to transfer all the needed data from the OpenStreetMap information to Hazus-MH. Now let's see the results. So far, I created the relation table only for the occupancy class for OpenStreetMap. With more research, it would be possible to define the different foundation types, first floor elevation, building types, and other relevant parameters for the flood damage estimation for each occupancy class. There are many variations possible, but let's leave this for the future. Now I will integrate all our processed data into our study region, Vilnius area, and will proceed with analysis. The framework should be already good known for you. Import the flood depth grid, then choose the units. Type in the return period. It will not play any significant role in the analysis. Create the new scenario and choose the segments of the flood depth grid. Then what left is the delineation of the flood boundaries. Next step, importing the user-defined facilities. Also, this should be already known operation for you, and it should be easy, because the template makes it easy. Select the table of user-defined facilities and match the fields. Looks like we have everything what we need. The last step is to run the analysis. I already mentioned that the speed of the analysis depends on the flood affected points. So I would recommend to add only these points, not the buildings, as example from the whole Germany or Lithuania. The results will show us the damages of the buildings and contents in the monetary value or the percentage. Looks like this is all what I wanted to show you this time. I'm very thankful to my both supervisors and the staff from the Policy Center in Indianapolis. During the last 2 months, I got invaluable experience here concerning the flood hazards and data management. If you have any questions, do not hesitate, just let me know. Thank you for your attention.